How's everyone doing? Welcome, welcome. I hope you've been enjoying day one of Cloud Next so far. My name is Nate Keating. I'm a product manager on Google Cloud's AI platform, focusing on AI Hub, which I'm really excited to talk to you about today. Before I get in, just a reminder that you can fill out a survey for any session that you go to or attend today. The surveys will open in the Google Cloud Next UK app about 20 minutes in. It's hugely important for us, right? This is how we get to understand what content you value, how we can iterate and improve each of our Cloud Next conferences every year, and how I can actually help improve my presentations when I'm talking to more customers or interested attendees. So I thank you in advance. I'll read all of the comments that come out of the session as soon as they're available, I promise. Before I get in, I kind of want to poll the audience a little bit, do a little straw poll. How many folks would say they're what I call an ML builder, like a research scientist, data scientist, machine learning engineer? You actually work on creating some part of the machine learning model getting into production. Okay, cool. How many would say they are managers of either individuals, teams, organizations that work on machine learning? Awesome. And how many are just neither of those and just like love to come to these sessions, learn about AI? Or their friends do AI. Cool, we love you too on the Cloud AI platform. And we hope to see you around if you're interested. Last questions. How many are currently using or have checked out AI Hub before? Awesome, so a lot of new folks to AI Hub. It's gonna be really great. It's a great introduction. It's a product that we announced in beta just a little bit earlier this year. So excited to share with you a little bit more. Brief walk through the agenda. I'll go through an intro, kind of scope out where we sit in the Cloud AI world, the Cloud AI platform, some of the pain points that we saw and we're hearing from all of our customers that led us to the vision of AI Hub, which is in part inspired from talking to folks like you, and other parts inspired by a lot of the great work that Google does internally across the hundreds, if not thousands, of people who need to collaborate on production machine learning that we have going on across all of our business units. And then I will pass the baton off to my colleague Mariana, who will walk through some simple demos to give you kind of like a sense of how you would use the product and bring it to life. And I'm super excited to bring on stage Atos to talk about how they're beginning to use AI Hub to solve some of their machine learning asset management and collaboration challenges that they have today. And then I'll wrap up with kind of like the next steps, how to get started and get engaged with us going forward. But let's jump in. Let me start with a mission statement you may have seen already. Cloud AI's mission, empowering every enterprise to transform their business with AI. And the key here is that, and I'm sure you all know this, we've moved beyond infancy for machine learning. We're in the era of what we sometimes call deployed AI, where teams are not just like experimenting to see if they can get something in production that works, but they actually have models in production already, are figuring out how do I actually improve these, build continuous delivery pipelines, and collaborate more effectively, taking the learnings they have from certain use cases to new data sets and new fields. So at Google, we've pioneered a ton of breakthroughs in the machine learning or AI space. But in Cloud AI, while those breakthroughs are like a big underpinning of a lot of our products, what really drives our product roadmaps and like our product thinking is not just what are the great breakthroughs, but what's really going to drive business value for all of our customers. So we take the best of Google's research and all the ways we do things internally and marry that with all of our customer conversations and the things we're hearing, the challenges that we're hearing that maybe even Google isn't running into across your industries. And our business is broken down into three areas. On the left-hand side, we have our building blocks, which you can think of just as like pre-trained machine learning models exposed through an API. Example would be the Cloud Vision API, kind of a classic example. Send in an image, comes back with a bunch of classifications. The key here is you don't need to bring your own ML expertise, and you don't need to bring your own training data. You can leverage the power of some AI without any of that already. On the right-hand side are solutions. These are larger offerings that seek to take an entire like horizontal or vertical business challenge and provide an AI-powered solution directly there to your enterprise. But today we're going to focus on this middle section, which is the Cloud AI platform, of which AI Hub is a major part. An AI platform, unlike the building blocks, is a place where you bring your own machine learning expertise and talent and business context. You bring your own training data, And what you're accessing is a huge tool set and a bunch of infrastructure that we provided to help you be more effective and more efficient in building machine learning models repeatably and reusably. And so what's the main pain point? Why does the Cloud AI platform exist? Pretty simply, it's really hard to do production machine learning right now. It takes way too long. Most of the customers I talk to will say that it takes over 6 months and sometimes up to, if not over, a year to get a brand new model into production. Let alone actually iterate on that model and improve it going forward. This image may be familiar to many of you. Comes from some canonical papers that the TensorFlow extended team put out about machine learning. So why is it so hard? And primarily it's because very little of what you do in production machine learning is actually algorithmic decisions or training a model. There's a whole host of things you have to think about and take care of, both in processes and technology. So you have to ensure that your training data and your inference data is similar enough that you're not going to get training serving skew. You have to handle auto-scaling, A/B testing, detecting bias, which is becoming more and more an important part of what we do here and part of our explainability offering that you may have heard about during our keynote. So these are just a few of the challenges that the Cloud AI platform tries to solve. And I think the analogy that really helps here is we see ourselves in some ways as like the assembly line for machine learning. It's not about like the innovation of building a car. Like we kind of have that not entirely solved, but solved well enough. What we need to do is build an assembly line that lets us build cars really quickly and roll out new models and new versions of cars really, really quickly. The way like 72 million cars get put out every year, I kind of think about a world where across all of the enterprises, we're building and putting 72 million new models in production at some point in the near future. That's the world that the Cloud AI platform is really trying to move towards. And of course, there's a bunch of different stakeholders across this entire machine learning workflow, right? And we try to provide tooling and collaboration ability across all these different personas and stakeholders. But today, data science is still largely an individual effort. Maybe not as bad as it was 5 or 10 years ago, but still today, most folks I talk to have an objective, have a data set, and kind of go off on their own and like hammer away at it for an extended period of time, a few sprints or months. Then all that experimentation work that they're doing, they may have learned a lot, and certainly they may have a better model because of it, but no one else has learned anything from this. And so if you are interested in figuring out why that model was better than the one you did, or why that model performed poorly, you're basically asking people. And none of that organizational knowledge is actually being shared or referenced unless you're doing extremely detailed documentation. I don't know if this resonates with anyone in the room, but I hear the data scientists themselves say that they don't even know why they did things 6 months ago. And so it feels like they're not even retaining the knowledge or the experience of their experiments and experimentation processes through time. And so this is the core problem that we are starting to tackle. And so some of these, again, may resonate with you here, is that there are tons of knowledge silos and redundancy in this world. I like to think of many of our product theses this way, which is, as organizations start to hire way more machine learning experts and data scientists, growing their teams, and as we start to offer tool sets that allow each data scientist to scale up how many experiments they're running and how many new models they're building, very quickly we're talking about 2-3 orders of magnitude more artifacts being generated across all of your machine learning processes, right? So we're gonna need better systems to handle and host and compare and document all of the machine learning artifacts that are being generated across the workflow, not even just models. And so how do I improve my speed of innovation by not starting from scratch every single time? How do I get a view of all of my organization models in one place, maybe filtered by which data set they were using or which features they're using? How do I trace the lineage of each of those models back in time and say, like, okay, what's the exact code that generated this model? What data set was it run on? Give me an exact snapshot of that data set so I can try and reproduce these results and iterate from there. How do I eliminate redundant work? If I've got a bunch of people in Europe and in the US working on similar data sets, trying to solve similar problems for their customers, how do I prevent them from basically trying the same exact things over and over again without realizing that they're both working on similar problems? And this is where AI Hub starts to come in. So AI Hub is intended to be the one place where an organization can manage all of their machine learning artifacts and therefore drive collaboration. And we do this primarily through 3 user journeys. First is discovery. Today, again, if you're storing most of your machine learning work on your local or inside a VM in the cloud, or maybe even using a Git-based source repository, it's still not search first. It's not intended to put in front of people who don't already know that that model or that notebook exists. And so what we try and build here is an index across all of your work, all of your machine learning components, so that people can search for relevant artifacts, whether they be data sets, features, notebooks, models, or pipelines, and make them easy for them to find, figure out what's going on there, and maybe take and iterate on themselves. The second is usage, right? This isn't just an index, right? I shouldn't just be able to find something, learn that it exists, and then still have to go ping someone and talk to them and set up meetings. I should be able to get a lot of context from this as well. So if I search for a model and I find it in AI Hub, I should have detailed logs. I should be able to open up a tensor board for this model. I should be able to compare it with some other models that I have as well. And then most importantly, all of these should be kept in warm storage so I can quickly deploy and run and test any of these pipelines or models or notebooks in the future. And last but not least is sharing, right? We don't have collaboration unless we have the ability to share things, but this also needs to take an enterprise-focused view. So while I do want to expand the circle of people who have access to my work and can learn from it and improve their own work, I also need to make sure that only the people who should have access to these do. And so enterprise-grade access controls and permissions as well as our standard across GCP. So where does AI Hub live in this standard GCP ML stack for those folks who are already doing their machine learning work on GCP? Of course, the core of any cloud offering, right, if you're starting at the bottom here, is infrastructure, compute, and networking, right? This is the standard thing that you get when you come to the cloud. On top of these, though, we've already provided a bunch of great managed services that make the backbone of the Cloud AI platform. And I won't go through all of them, but just an example, right? The AI platform training and prediction services let you run distributed training jobs on Google Cloud or do online inference without any hassle and just basically hand over the reins to Google Cloud's infrastructure, auto-scale as you need, do training jobs on insane number of servers, and they just spin up and spin down whenever you need them. But most data scientists probably spend a lot of their time in that tooling and SDK layer, inside notebooks, writing code in IDEs, using some of our SDKs to orchestrate pipelines, or do some explainability work. And the idea for AI Hub is that each of these lower layers are going to continue to generate more and more artifacts that today, again, just get put into a bucket or dropped into your local, and you lose context of why, when, how they were created. That AI Hub is the place where these maintain their context and can be surfaced going forward. I think at this point, it probably is just easier to give you a quick view of what AI Hub is. So if you can switch over to the demo machine, I'll just give you a quick overview and then pass the mic off. Actually, could you switch? And then Mariana, it'd be great if you came up. So what you're looking at here is the home page for AI Hub once you've logged in. And there's a lot to go over here, so I'll try and just really briefly point out some key updates before passing it off. So the first is that this top section looks very G Suite-like, and that's kind of intentional, right? You've got some quick access to popular assets that are uploaded and shared inside your organization. So we have a training pipeline here. We have a couple of notebooks that might be valuable. Below that, we have new assets that were recently shared with you, just again for quick access. Below the fold, though, we actually have a separate section of AI Hub where Google has open sourced and provided hundreds of machine learning assets that might be relevant to you. So the first section here is production-ready assets, and these can be some standard VM images that you might want to use, some pipelines that take data out of BigQuery and do some pre-processing, or even full end-to-end pipelines. Another row here, another shelf for Kaggle, which is now part of Google Cloud's AI platform. For those not familiar, Kaggle is the world's largest data science community with millions and millions of active members, and we've actually gone through and curated the top Kaggle kernels that we think are valuable for enterprise, and are in the process of doing that on a regular and frequent basis, so we're updating this curated section of machine learning assets, which may just be relevant for educational purposes, but you may also find valuable for building on your enterprise use cases. And last but not least, what would we be if we didn't provide quick access to all the cutting edge research that Google and DeepMind and our cloud AI research teams are putting out there? I think another thing to point out here across our public catalog is we have a few other asset types. So besides machine learning pipelines, notebooks, some of our APIs and services, we also have TensorFlow modules. So for folks who aren't familiar, this is like a checkpointed TensorFlow model that you can take and do transfer learning on. So for example, if you don't have enough data to do a full, to build a model on your use case, you can take a checkpointed model from one of these TensorFlow modules, train just the last few layers for your specific use case, and run this going forward. I already mentioned we have VM images, a place for trained models, and these would be like the model binary files, like a TF-save model. And last but not least, we have technical guides in the public catalog, which are kind of like these long 20+ page detailed guides on how to set up a more complex machine learning system with an attached source code repository for you to actually just run and get it up and running. A couple other things to quickly point out just from the homepage. Any of the assets here you can actually star, which is a great way to bookmark them. And then you can see your starred assets just from a quick access here on the left-hand side. So if there is something that you find super valuable and want to come back to, you can just quickly grab it right there. You can also search, so let's say I want to look at assets that use Keras, and I immediately pop up a bunch of notebooks here, all using Keras, 211 of them here, which may be valuable for any of your use cases or for learning more about how to do deep learning in a fairly simple manner using the Keras API. Last but not least, you get quick access to all the assets you've created in AI Hub right here. So under the My Assets page, you can see a list of, and this is just the few that we have in our demo environment here, assets that you've uploaded, with quick, easy sharing icons, and then icons to show which have already been shared and which version number you're looking at. But to get into any more depth about how to actually bring your assets into the AI Hub ecosystem, I'll pass it off to Mariana to go through some more detailed demos. Thank you.
Thanks, Nate. I'm Mariana Quinde Garcia. I'm a software engineer for AI Hub, and I'm very excited to show you what we've been working on for the past few months. So let's jump into it. Let's say I'm a data scientist, and I just built a notebook, which I want to share with some people on my team. AI Hub allows you to share the source file, the metadata, and version information for your asset in just a few clicks. And so for example, right now, I have a notebook on my laptop which builds a binary classification model. And I'll run you through that notebook in a bit, but first I want to show you how to upload and use it in the AI Hub. So I click on this top left button, select what I want to upload, a pipeline, a model, or a notebook. I'm going to select the latter. And first, I'm going to enter some metadata for my notebook. Let's call this house pricing classification. I'm going to set the input data to tabular. And now I'm going to enter some optional additional metadata that will just make my asset easier to discover in AI Hub for anyone who has access to it. So I'm going to specify that this takes me end-to-end in the machine learning workflow, and that it uses the classification technique. Gonna type a brief summary, type very fast. Click next, and in this step, I can actually upload the IPython notebook file. The last step, I preview how it will look once I actually submit this. As you can see, we render the notebook and the metadata that I previously entered. And once I hit submit, I'll get a confirmation that my asset has been published, if the Wi-Fi allows. And just like that, my notebook is now an asset in AI Hub. Now what can I do with this? Well, as of now, it's only visible to me, so to the publisher. But once on the details page, I can just click on share and share it with whoever I want. So I can either give everyone in my organization viewer permissions, or I can specify a user through their email and give them viewer or editor permissions if I want them to be able to update my asset. So for example, I'm going to add Nate's Google email if you want to hit him up. And as you can see, I'm demoing from another organization that's not Google. So once I click on add, I'm going to get a flag that just warns me that this user is not in my same organization, just to make sure that you actually want to share it with them. I click on save and confirm the changes. And now my asset is visible or editable to whoever I gave access to. And this puts my asset in AI Hub's ecosystem. It kicks off the collaboration process and allows other users to see, share, and update my assets in just a few clicks. And not just that, but once on this details page, whoever has access to it can download the source file that I uploaded, or they can choose to deploy the notebook directly in GCP by clicking on this button, which I will now show you. This is redirecting me to Cloud AI Platform Notebooks, which is a product that was announced in beta back in April. And it allows you to run hosted notebook instances in the cloud in a very safe way without having to worry about the underlying infrastructure. Each instance comes preloaded with the most popular libraries in data science and machine learning. You can also add your own libraries. You can change the environment, switch up the compute power as you see fit. And it's just a very easy way to run your notebooks. So I select that instance, click continue, and this opens my notebook on Jupyter Lab. And in the interest of time, I have pre-ran the notebook before. And as I told you before, this notebook builds a binary classification model using XGBoost. It trains a model which predicts whether a house is under or over $160K, which is around 124K pounds, if my math does not fail me. Then it deploys the model to the Cloud AI platform, and it uses the what if tool, which is a new feature that I'm excited to show you in a bit. So I really just have time to blaze through this notebook, but let's get to it. I do some initial setup. I import libraries, which, as I said, is very easy because the instance is already preloaded with them. In the second section, I get my data. I prepare it, I drop some columns that are not that useful, and end up with this information about houses that includes square foot, the neighborhood, what year it was built, if it was remodeled, how many cars it fits in its garage, and my label, which is the sale price. I do some feature engineering, I dummy encode the categorical columns, and I turned this into a classification problem by converting the label, so the sale price, into a binary format, so a 1-0 on whether it's over 160K. I split my data to train and test and train my model using XGBoost, resulting in a model that's 92% accurate, which we'll do for now. And in this next section, I deploy it to AI platform by selecting a project, a bucket, and in a few minutes, I've created its first version. It's been deployed. And once it's deployed, I can use the what if tool to interpret the results. And in case you haven't heard of it, the what if tool is a visual interface that helps you understand your data set and your model results. It's very easy to use. As you can see, we're instantiating it right here with only a few lines of code. We are inputting our test data, selecting a notebook, and selecting the target feature, and passing in some vocabulary. And when I run that, this renders the tool that you see right here. We are first dropped into the data point editor, which shows us our model predictions for each of the data points that we passed in, so each of our test data points. And in this case, we see the blue points, which are houses that our model predicts are over 160K, while the red points are predicted to be under that price. And the closer the points are to the middle, the less confident our model is about their classification. And a cool thing to do in this editor is I can inspect individual data points. So for example, I just clicked on that, and on my left, I can see the feature values, and I can actually edit these values to see how they affect the model results. So for example, I'm going to switch this up. I'm going to say that this house was remodeled in a more recent year. I then run inference on it, and I can see how this affects my model. As you can see, my model now is highly confident that this house is over 160K. And this example is rather intuitive, but as you probably know, understanding models can get way harder in real-life examples. And it's very convenient to have a tool like this at hand. On the second tab, we can see how our model performs on some common metrics. We can also optimize for fairness. And on the last tab, we can see how balanced our data set is. And as you can see, there's a lot to do with this tool, a lot of options. If you haven't yet, I would recommend that you take a look, especially given how increasingly important it is to really understand our models and make sure that we are trying to decrease bias and just developing AI responsibly. So that's the what if tool. Now let's say I make some changes to this notebook and I want to update these changes in AI Hub. Well, I'm going to show you a feature that we're working on currently, and it will let me do this very easily. So this is the notebook that I just deployed, and as you can see, we will soon have this plugin in Jupyter Lab, the button in the toolbar, which will allow me to upload the notebook to AI Hub. So with just one click, and this redirects me to AI Hub, where I'll be able to choose whether I want to upload this notebook as a new asset, or I want to update an existing notebook with a new version. So I select the notebook that I want to update, click Save, and a new version of this notebook is created. I can see it on the details page, and I can share it as I've previously showed you. Yeah, so that wraps up the demos. So far, we've shown you how you can discover a notebook in AI Hub. You can also upload your own, share it, get it running on GCP immediately, and once it's there, you can play around with it to discover new techniques, plug in the what if tool, and all these tools really increase collaboration and smooth out the onboarding process by allowing you to make your assets easily discoverable and usable, along with the what if tool, which just increases debuggability, transparency, and fairness. And to talk to you more about how they use AI Hub to increase collaboration within their organization, I leave you with Richard Hacking from Atos. Thank you.
Good afternoon. So if we could just flick back to the slides, cool. Excellent. So my name is Richard Hacking. I head up Atos's UK and Ireland AI lab, and it's a real privilege to speak to you today. So I don't know how many people know about Atos. We've got over 7,700 experts who work in data and artificial intelligence, working on projects with our clients globally on everything from value consulting through to data visualization. And then also over the last year, we've created 5 Google AI labs where we work with customers to help them co-innovate and look at what's the art of the possible. How can data help you to get more value into your business? Within the AI labs, we have this proven process that we use. We really start at the ideation phase. So there's lots of things you can do with your data, but it's really key to make sure that we can try and work on what would a good use case be where it delivers value into your organization, and we think that there's the underlying data to support a useful exercise in that. So we'll work with clients to identify a good problem area to look at, and then we'll then hold an AI lab session, which could be anything from 1 to 2 days. And we'll invite people from the organization that are involved in the end-to-end process. We get multiple perspectives of how that process would work. And if you've got data that you can share with us, then we'd bring that into the session. And we go through this 3-phase process. So the first process is really about discovering what can AI do. So given the use case, we'd look at how do other organizations in your industry tackle that issue? How do other industries maybe tackle that issue to give different perspectives and to give a bit of inspiration about what the art of the possible is and what AI technology can do today? The second phase is all about design. So again, we want to build upon how processes work at the moment. So we'd use a design thinking approach to understand how does the process work today? What are the pain points? So where is the cognitive load where people are having to think a lot, or we find lots of error rates in processes, and we'll brainstorm on where would good places be where AI could intervene and help. And sometimes through that design phase, we'll look at multiple solutions which might not be AI. It might be a automation or an analytics type solution. So again, we can say, is this a good problem for AI, or is there a better, cheaper way of doing it? And then we do the define side, saying, from that design phase, we've got a hypothesis. Given data that we might have used in the lab, we've done some initial feasibility assessment on, do we think this is a good thing to do, and how would it work? And then on the define stage, we then define a roadmap of how can we prove that? What are the KPIs to know whether this solution will work? And as well as looking at the technical solution, we'll also look at what are the other things to do to get acceptance into the organization. We find a lot of clients, they can do the technical proof of concept or the minimal viable product, but to get users to use it, you need to look at that change management piece, the business case, the sponsorship, and we can plan all of that in. And for this to be successful for us, it's really key for us to be able to work at pace, to be able to build on proven components used before, so that we can actually spend the most valuable use of that time that we have together to sort of see what the best possible way forward would be. And some of the challenges we have when we're doing these projects with clients are listed on the board here. So the first one is about collaboration. So although we have our UK&I lab in London, my team is spread across the UK, and we also work with our global colleagues in other countries. And it's really key for us to be able to bring the right expertise to a problem. So again, it's knowing who's worked on similar projects before, and then being able to collaborate on one system in one way, even if they are not physically in the same location as us. Best practice is really a key point for us as well. So again, we want to be able to use the same tools, the same approaches where possible to make sure that we're actually building upon work done before. And it's really key for us to be able to quickly identify how has this been done before in our organization, what are the lessons learned that we've had from previous implementations, so that we're not starting from scratch, we can build upon the work we've done elsewhere. And the third thing that we find about agile projects is that there's a lot of experimentation that we need to do. And again, for the amount of experimentation that we're able to do within the time that we have directly contributes to the quality of the end solution that we have. So both in our labs experience, where we're doing the design, we might experiment with different ways of solving a problem to try and work out what would be the best way forward. When we're actually going into the delivery projects and we're starting to actually use real data and starting to put it through more mature ways of working, again, we want to experiment on what's the best way of doing it. If we augment in our data with other data sources, does that improve the model? Does that improve our accuracy? And we need to be able to work at pace to be able to drive that quality. So here's an example of some of the AI, of our use of AI Hub at the moment and some of the notebooks that we use. And again, we find it really helpful to have all of our notebooks in one place, one screen that we use globally, so that anyone in our company can see where have we done things like this before. We're able to tag our notebooks on like the types of problem domain or the types of technical functionality we're using. So it's very easy to search through and see what other projects have we done that are very similar. So again, we can build upon previous proven products and then learn about the limitations of them and say what's the best way forward. And one example would be, I was speaking to a client on Monday, and we're looking at doing some work about predictive maintenance on smart fridges. So they've got a fridge, they've got data on that, on how it's operating, and it's saying, well, can we help them predict when that fails? So therefore, we can intervene in advance so we don't lose the expensive contents inside. And again, we were able to look at this, and looking at the third one down, we've got PCA lab analysis. So that PCA means principal component analysis. So if we're trying to predict failure, which are the components in the data sets that give us the best insights into when a fridge might fail. So it might be when we see variations in the temperature, that's a lead indicator saying that fridge is going to fail in 2 days' time. We've got a proven model here as a starting point so that quickly we can start saying what are the key features we need to look at so we can hone in quickly on what are the right elements to try and get that accurate prediction of when a fridge might fail. Second one down from the bottom, asset location visualization. We did a similar project with another client last year, and again, we've uploaded that notebook into AI Hub now. So again, we've got something out of the box that helps us visualize some of that data in there, so we're not starting from scratch, we can build on that, and everyone globally in our company is contributing to the same knowledge repository for us. And again, this is available to everyone who's got the Google license within Atos to be able to build to this, contribute, and build forward. So some of the benefits that we're getting, the first one here is about quick onboarding. So of the 5 AI labs we've got, 2 of them have only started in the last 3 months in Dallas and Munich. What we found with using AI Hub is that from day one, these new teams that are newly formed have access to all of the algorithms, the data sets, the models that all the other labs have built previously. So from day one, they can build upon the stuff we've got and then contribute to that AI Hub going forward. So it's not a new team working in a silo, developing new ways of working. We've got that central knowledge base, so again, it's very easy to search through all the different artifacts we've got to see where have we done this before, what's worked, what's not worked. And the third thing is about best practice, so it's helping us to drive good governance, good standard tool sets and approaches so that we're actually working the best way. So things like bias and fairness is something that we hold dearly, so especially when we're looking at sensitive areas with data which could impact how a citizen's treated, we want to make sure that we're testing for bias in the data set, we're testing for bias within the algorithm, and again, we've got proven ways here of how we're doing this, so we're not starting from scratch each time. We can build upon standard testing approaches to improve the quality and the pace at which we can work. So looking forward, we've been working with Nate and the Google team now for quite a while, and again, these are some of the features I'm really excited that hopefully will be coming into AI Hub in the near future. So notebook reproducibility. Again, when you're actually developing a notebook, the underlying infrastructure might change. By being able to store some of the context of the environment with the notebook, it helps you to make sure that the notebook will work or be able to debug it quite quickly. On the rich machine learning metadata, this is all about, as well as storing the data, storing metadata about that. So if we were able to store data about what data set was used for training a model, how long was it trained for, what are the limitations of that model, that means we're saying we're looking to do a new project. We've got 3 examples of where this has been done before. That metadata can help us work out which is the best one to use for this model. So again, it's simplifying the exercise of the data scientist to be able to get the right solution first time. And then data discovery, being able to extend the ability to search within AI Hub to be able to look across multiple data sets, multiple models over public data as well. Again, it'll only accelerate the time, so we've got one window to look at all these things. So that's my little bit. If anyone would like any more questions about this afterwards, happy to speak after this session, or I'll be on the Atos stand in the center of the floor, and happy to take questions on using AI Hub effectively or wider on how AI could actually help your organization. So with that, thank you very much. I'll hand back to Nate.
Thank you, Richard, Mariana. It was awesome. Let me take this home. So I want to talk a little bit about what's on the horizon for us, right? So, and before I do, I want to talk a little bit about AI Hub's current position and where we're focused on our main themes going forward. So the first is you've already seen primarily examples of a notebook, of how we can use AI Hub to store this notebook with context, share it with others, quickly run it on GCP, especially great if you guys are already using AI Platform Notebook service. But you may be thinking like, okay, what do I use today? I use something like GitHub or something like that for this process. And GitHub is great, or other Git-based source control systems. We love using them, and we use them as well ourselves. But there's a lot to be desired when it comes to data science in this area. One is that models and notebooks can get very large. And like source control repositories will blow up, especially as you start versioning them. I think we did some studies recently, and that like roughly it takes about 4 months or 5 months when we see a data science repository to get to the same size or exceed the size of like 10 years of software engineering repositories with thousands and thousands of commits. And that's because you're basically storing a whole new copy of that notebook or that model every single time you're versioning. So you need a better system to manage these that actually, one, is better for larger images or larger objects, but also understands what they are. And the context is so important for machine learning artifacts, is to Git, stuff is just a file. And to AI Hub, it's a notebook and it's a model, and which means we can show you detailed metadata and lineage about these items, especially if they're automatically created on Google Cloud's AI platform. Which leads me to our main themes for what we're working on going forward. The first is easy asset ingestion. So we showed you today how you can use our GUI to upload assets. But of course, for things other than notebooks in particular, that's not going to be the best method for actually adding my assets to AI Hub's ecosystem. And so what we're really focused on is providing a programmatic interface for you to build AI Hub into your existing workflows. This could mean, one, actually integrating with your Git-based workflows, but also providing an API to use as well. So I would stay tuned on that item. This is going to be really, really great for particularly storing models and pipelines. Second is greater integrations with the rest of the AI platform. Like I said earlier, one of our key principles here is that all of your assets can really quickly be deployed and run on other cloud AI platform services, and vice versa. So we want to make it really easy for the things you create on the AI platform to automatically be available in AI Hub's ecosystem for sharing with all of their detailed metadata. And we also want to make it very easy for any asset in AI Hub to automatically be deployed, a model for batch prediction, or just for testing on a new data set. So everything should be aspirationally one-click deployable in a reproducible manner. This includes some of the notebook reproducibility work that Richard alluded to, which is basically the idea that if you're running your notebook and creating your notebook and authoring your notebook, I should say, on Google Cloud's AI platform and storing it within AI Hub, we should be able to maintain the context of the environment that was running that notebook and make it much more likely that you can open that notebook up in a compatible environment the next time you try, so you don't run into the situation that I hear about all the time where, again, 6 months down the line, you can't figure out why this thing that you created isn't working as expected. And last is enhanced collaboration. So we showed you today how you can share things and you can edit and update assets and update their metadata. But collaboration just starts with sharing, right? Once you put things in people's hands, there's a whole host of collaboration workflows related to the machine learning model lifecycle development, like as things go through stage gates and approvals and evaluations, that we'll be building into the product as well. So super excited about all this to make machine learning a much more collaborative effort and try and reduce the redundancy and increase the visibility, traceability, and auditability even of all of the machine learning artifacts that you guys are creating in your organizations. And that wraps it up. AI Hub's in beta today. Please feel free to jump in and check it out. Any organization that uses G Suite can automatically, from day one, share assets across their organization completely free. If you're interested in the notebook that Mariana walked through, in particular the What If tool, which is an awesome tool for explainability, that notebook is actually available in AI Hub's public catalog, so all you have to do is search for What If tool XGBoost or something like that, and you can grab and run that right away. On our homepage, we have a link to a community which you can join, where you'll see some regular updates or chat with us, raise bugs or feedback. And of course, any of the upcoming features that you may have heard about today, or just ideas, please feel free to reach out. I will hang out right here after the session, and I'm sure I'll get kicked out, and I'll be waiting outside for the rest of the afternoon if you have questions or input. Thank you again for coming. It's been an honor to be here, and I'm looking forward to hearing from a lot of you in the future. Thanks again.